wave functions of individual cells within the pellet. Let's go on level deeper in explaining my hypothesis. The required input energy for fusion can be reduced almost to zero based on what was described above. But for that, one must tune the reaction environment at the level of the particle's wave functions. Now, the theoretical LENR theory comes into play. Let's consider chemical catalysis, a long-known process widely used in industry, from the standpoint of my hypothesis. Catalysts for the same group of reactants can have vastly different efficiencies. One may accelerate a reaction twice, while another 1,000 times. At the same temperature, both catalysts reconfigure the electron clouds of the reactants to overcome the reaction's potential barrier. A more effective catalyst must configure more parameters of the reactant's electron clouds than a less effective one. Its structure must therefore be more complex. Principle: more parameters, less input energy. Essentially, the catalyst's structure reconfigures the reactant's cloud structures. More precisely, the wave function of the catalyst's electrons overlap with those of the reactants, forming a new composite wave function with a higher probability of reaction. There is another way to increase reaction frequency by heating the solution to, say, 200 degrees, spending extra energy. But remember, a catalyst can be reused many times and does not add energy to the system. So catalyst equal energy. Configuration can replace input energy. Is it possible to build low-energy fusion device? In principle, yes. But what is the fundamental difference between a heated solution and catalysis? Let's add another layer of understanding. Let's view chemical reactions through the lens of quantum thermodynamics. In a heated solution, molecules move faster than in cold one. As quantum objects, molecules collide and detect each other, materializing their random parameters from a range of probabilities. If parameters overlap correctly, a reaction occurs. The same happens inside the Sun for fusion reactions. An important fact: the first reaction, the fusion of two protons into deuterium, is impossible without quantum tunneling. Essentially, temperature, density, and confinement time, Lawson's criteria, are just nature's way of rapidly cycling through possible combinations, like a blind man trying to open a safe by spinning its dial. If the blind man works faster, trying more combination per unit time, the probability of randomly opening the safe increases. What distinguishes the successful combinations from the trillion of others? From nature's viewpoint, nothing. Temperature, time, and density are simply functions of how quickly nature searches through combinations. In practice, these parameters become megajoules of input energy. Thus, we can draw an important conclusion. Structuring a catalyst introduces an engineered wave function for the electron clouds, reducing the required input energy. In contrast, without a catalyst, a heated solution needs much more input energy and/or time and density to perform blind trials of incorrect combinations, more molecular collisions per unit time. There is no magic here. If low-engineered entropy is so important for fusion, why do they create high-entropy Maxwellian plasmas and then struggle to tame that frightened horse? Doesn't that seem redundant in the light of ILE? Maybe we should first configure the reaction environment properly and only then supply it with energy, not the other way around. The task of fusion comes down to creating a structured environment, generating an ultra-short trigger pulse for the final tuning of the wave functions of individual structures within the pellet, ensuring that the fusion process occurs collectively, while the triggered pulse does not have time to destroy the uh, predefined structure of the pellet. Likewise, the individual fusion reactions do not have time to disrupt the environment. Entropy does not have time to increase. Recommendation for engineers: use a cleaner laser with use a cleaner laser with a shorter wavelength. Introduce more control channels for the reaction environment and machine systems. This applies to every level. Increase precision of environmental tuning to achieve required parameters. Prefer low entropy reaction environment to Maxwellian plasma. Structure the pellet at smaller scales. Keep the impulse duration short, since time is a function of entropy growth. Calculate cheat codes for parameters, the magical combination, the golden ratio. Timing and operational algorithms of the device must also be complex. Please support my hard work developing this hypothesis through donations. It may help to create viable fusion. Next, I plan to analyze how my hypothesis applies to the NIF experiment and what practical improvements could be made there. I will also develop my hypothesis further in the framework of Shannon entropy, information theory, and Feynman entropy.